Have you ever looked up at the night sky and wondered about those faint, fuzzy patches of light scattered among the stars? They might seem like distant, blurry stars, but they are actually some of the most spectacular and dynamic objects in the universe, nebulas. These are nature's celestial fireworks, vast clouds of gas and dust where stars are born and where they end their lives in breathtaking displays. Today, we are going on a deep dive to explore these cosmic wonders and understand how we get to see their incredible glow from billions of miles away. So, what exactly is a nebula? The word itself comes from Latin, meaning cloud, and that's a perfect description. They are interstellar clouds of dust, hydrogen, helium, and other ionized gases. But they're not just any clouds, they are the fundamental building blocks of the cosmos. Think of them as stellar nurseries and cosmic recycling plants all in one. Let's start with the most famous type, emission nebulas. These are the supermodels of the nebula world, known for their vibrant, glowing colors. A fantastic example is the Orion Nebula, visible to the naked eye as a fuzzy star in Orion's sword. This massive cloud of gas and dust is a stellar nursery, actively forming thousands of new stars. The reason it glows so brightly is because of the young, hot, massive stars embedded within it. These stars blast out intense ultraviolet radiation, which energizes the surrounding hydrogen gas. This process, called ionization, strips electrons from the hydrogen atoms. When these electrons recombine with the atoms, they release energy in the form of light, creating that beautiful reddish-pink glow characteristic of so many nebulas. It's like a giant cosmic neon sign lit up from the inside. Then we have reflection nebulas. Unlike their emission cousins, these nebulas don't produce their own light. Instead, they act like cosmic mirrors. They're typically located near stars that aren't hot enough to ionize the gas. The dust particles within these clouds scatter the starlight, much like how fog scatters the light from a car's headlights. Because blue light scatters more efficiently than red light, reflection nebulas often appear a ghostly blue. The Pleiades star cluster, also known as the Seven Sisters, is surrounded by a stunning blue reflection nebula. It looks like the stars are wrapped in a delicate blue veil, and it's all thanks to starlight reflecting off ancient cosmic dust. Next up are the dark nebulas. These might sound a bit ominous, but they are just as important. Dark nebulas are so dense with dust that they block the light from whatever is behind them, whether it's a bright emission nebula or a field of distant stars. They appear as dark patches or silhouettes against the luminous background of the Milky Way. A famous example is the Horsehead Nebula, which is actually part of the larger Orion molecular cloud complex. The iconic horsehead shape is a dense pillar of dark dust and gas, silhouetted against the bright red glow of the emission nebula. I see 434 behind it. These dark clouds are incredibly cold and dense, making them perfect places for new stars to begin forming, hidden from our view until they burst into life. Finally, we have one of the most dramatic types of nebulas, planetary nebulas. Now, the name is a bit misleading. They have absolutely nothing to do with planets. The term was coined by early astronomers who thought their small round shapes looked like planets through their primitive telescopes. In reality, planetary nebulas are the final, glorious farewell of a dying star, a star similar in mass to our own sun. As the star runs out of fuel, it can no longer support itself against its own gravity. Its outer layers drift away into space, forming an expanding shell of glowing gas. The hot, dense core of the star, now a white dwarf, remains at the center, bathing the expelled gas in ultraviolet radiation and causing it to glow. The Ring Nebula is a classic example, a beautiful cosmic smoke ring that shows us the future fate of our very own sun, billions of years from now. But what about the truly massive stars? They go out with an even bigger bang. When a star more than 8 times the mass of our sun exhausts its fuel, it collapses and then explodes in a cataclysmic event called a supernova. The explosion blasts the star's material out into space at incredible speeds, creating a supernova remnant. The Crab Nebula is one of the most famous supernova remnants. It is the remains of a star that was seen to explode by Chinese astronomers in the year 1054. Today, we see a tangled web of expanding gas filaments, still glowing with the energy from that ancient explosion. These remnants are cosmic recycling centers, seeding the galaxy with heavy elements like oxygen, iron, and gold, the very elements that make up planets, and even us. So we've talked about what these nebulas are, but how? Do we see them in such stunning detail? Our eyes can only see a small fraction of the light spectrum. To truly unlock the secrets of nebulas, we rely on powerful telescopes like the Hubble Space Telescope and now the James Webb Space Telescope. These incredible instruments can see far beyond the visible spectrum, into infrared and ultraviolet light. Here's why that's so important. Different elements in a nebula glow at different wavelengths, or colors, when they are energized. For example, glowing hydrogen often appears red, oxygen looks greenish-blue, and sulfur shows up as a deeper red. Scientists at NASA and other space agencies can assign specific colors to these different wavelengths, even those our eyes can't see. This is called false color imaging, or what some call a palette assignment. It's not about making the images look pretty, although they certainly do. It is a scientific tool that allows us to distinguish the different chemical elements and physical processes happening inside the nebula. For example, when you see a Hubble image of the pillars of creation within the Eagle Nebula, those incredible colors tell a story. The blues and greens might represent oxygen, while the reds indicate hydrogen and sulfur. This allows scientists to map out the chemical composition and temperature of the cloud. The James Webb Space Telescope takes this even further. By looking in infrared light, Webb can peer through the dense dust clouds that block visible light. It can see the newborn stars hiding deep inside dark nebulas, revealing the very first stages of star formation that were previously hidden from us. Its recent images of the cosmic cliffs in the Carina Nebula have given us an unprecedented view of this stellar nursery, revealing hundreds of previously unseen stars and intricate structures of gas and dust. So every time you see one of those breathtaking images from NASA, remember what you're looking at. It's not just a pretty picture. It's a scientific masterpiece, a visual translation of complex data that tells the story of our universe. From the glowing nurseries where stars are born, to the beautiful swan songs of dying stars, nebulas are the heart and soul of the cosmos. They are the dust from which we came and the stellar fireworks that light up the infinite darkness. They remind us that even in the vast emptiness of space, there is a cycle of birth, life, and death that is both chaotic and breathtakingly beautiful. Thanks so much for joining me on this journey through nature's celestial fireworks. If you enjoyed this cosmic exploration, don't forget to hit that like button, subscribe, and ring the bell so you won't miss our next deep dive into the wonders of the universe. See you next time.